Yellowstone nears eruption as a new study finds magma bubbling beneath the surface. We may have underestimated the potential for a future Yellowstone eruption. Chinese scientists have made alarming findings regarding the mechanisms behind the caldera eruption, sparking fears that the volcano could be spewing lava more rapidly than expected, according to an explosive study in the journal Science. Contrary to previous research suggesting that magma originates from large, deep chambers, the new study suggests that magma may be lurking just beneath the Earth's surface. The team from the Institute of Geology and Geophysics of the Chinese Academy of Sciences was studying the drivers behind supervolcanoes, volcanic eruptions that eject more than 230 cubic miles of magma, rock, and ash. As one of the most catastrophic geological events on Earth, these eruptions can have devastating impacts on the environment and human civilization. The Yellowstone supervolcano, located beneath the 30 by 45-mile Yellowstone Caldera, has produced 3 super eruptions in the past 2.1 million years, according to the U.S. Geological Survey. If one of these eruptions occurred today, the impacts could be global, including massive pyroclastic flows. A foot-high layer of toxic ash would inundate the Midwest, and the damage to agriculture would result in estimated losses of up to $3 trillion and risk millions of lives. To explain the mechanisms behind magma formation in supervolcanoes, the team has designed a comprehensive 3-dimensional model of Western North America.
The model simulates the current dynamics of the lithosphere, Earth's cold outer layer, and the asthenosphere, the hot, slow-flowing, and ductile mantle beneath it that fuels volcanic eruptions. Previous research has suggested that supervolcanoes harbor large magma reservoirs that build up molten rock until the pressure becomes too great to trigger an eruption. However, these reservoirs are conspicuously absent from large supervolcanoes. Using this new model, however, the team discovered that the eruptions were generated by a much shallower source, a vast zone of partially molten rock called a magma slurry system that permeates much of Earth's lithosphere. Magma originates in the upper asthenosphere and rises to the outermost layer where it mixes with the denser surrounding rock to form a thick magma slurry. However, the mechanism behind how this magma melts remains unclear. Meanwhile, hot rock continues to flow eastward beneath the caldera, tearing apart the hard lithosphere and forming a conduit through which molten rock can rise and replenish the volcano's mud reservoir. This means that the supervolcano can replenish its magma supply solely through tectonic activity without the need for a deep lava chamber. Fortunately, Yellowstone is not scheduled to erupt anytime soon. Based on 3 previous eruptions, there has been an average of about 725,000 years between each event, meaning we technically still have 100,000 years before the next one. And as USGS experts point out, this is based on the average of only 2 intervals between eruptions, which is not meaningful.
Faithful. For centuries, we've thought of it as a mere